in probably 12 to 15 passes, the rods are garbage. The small end of the rod is just an oval, and you can just bang the wrist pin around. So.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Devin Schultz from Boostin Performance. Boostin has made a bit of a name for themselves recently with their Red Demon Talon Eclipse, mainly because it is the fastest DSM and Mitsubishi four-wheel drive for that matter in the world, running as quick as a 6.97 at 213 mile an hour, which is absolutely insane. This episode is pretty tech heavy and is going to be of great interest to anyone with a bit of a passion or interest in the Evo and 4G63 platforms. We dive deep into what's involved with building an engine that can reliably make 2,000 horsepower. And on that note as well, what reliability can we expect when we're building engines that make this much power? And you might be unsurprised to find out that no, these engines aren't going to go 100,000 miles between services or inspections. We also dive deep into Devin's background, how he got involved in cars, how he learned to spin spanners and then move into the tuning industry, and then of course how he decided to take that leap of faith and start Boostin Performance. Before we get into our chat with Devin, for those who are fresh to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, tune factory and aftermarket engine management systems, build wiring harnesses, and a host of other topics. And we do this all with online video-based training courses that you can take from anywhere in the world as long as you've got an internet connection. As a podcast listener, you can also use the coupon code podcast75, and that'll get you $75 off the purchase of your very first HPA course. We'll put a link to the courses page of our website in the description, as well as that coupon code, making it really easy to find. Enough with our introduction though, let's get into our interview now. All right, welcome to the podcast, Devin. Thanks for joining us today. I've been following your achievements, particularly in your Red Demon Talon Eclipse, which we'll dive into in a bunch more detail. So I'm pretty excited to talk a little bit about your career and that car specifically. Before we get into that though, let's get a little bit of insight into your background. So how did you get involved in cars? How did you get interested in cars in the first place?
Sure. So I would say the passion kind of started when I was at home with my dad, and he'd be working on the family car. You know, he wouldn't do anything major, but, you know, he'd be doing the brake jobs or changing the radiator, doing something simple to the car. And, you know, I was always out there helping him, shining the flashlight in the wrong spot, you know, grabbing the wrong tools. So
losing the 10mm sockets.
Yep. You know the deal. You've been through it.
So at what point did that sort of turn into getting your own car, and what direction did you go? I mean, obviously at this point you're sort of into the JDM market. How did that go in that direction?
Yeah, so, you know, I've kind of thought about that, and I would say the one point that I keep kind of remembering as a kid was my brother had an 87 Dodge Daytona CS. It was like the Carroll Shelby version that was turbocharged, and I remember he would take me to karate class every once in a while, and I remember the boost gauge in that car and just being interested in, like, you know, what is that? What is it doing? And why does the car feel like that when the gauge goes up, you know? So I just remember that. And I think that's kind of what sparked my interest in, you know, forced induction and performance cars. And, you know, I was maybe 6, 7 years old, and my brother would be taking me to karate class. So
there's a bit of a disconnect between watching a boost gauge on your way to karate class and what you're doing now, clearly. Can you fill in some of those steps along the way? Is there any formal qualifications that you've taken in order to do what you do now, or has this all been self-taught?
Yeah, so I went to the College of DuPage, which is a community college local to me. So I have an associate's degree in automotive and general education. So I got like their 2-year degree for both of those. And from there, I was street racing with my car and, you know, taking care of all of my buddies' cars at this point. So, you know, we were all kind of getting set up for racing, and they would see the success with my car, and then I would just, you know, start messing with their car. So it just kind of went from there. You know, it went from, you know, helping out one buddy to, you know, their car started working really well, to helping out another buddy, to, like, hey, this guy will pay you to help him. I'm like, okay, sure. So that just kind of grew from there. It wasn't anything that I was like, hey, I want to be a tuner. This is like, what I want to do, until kind of later on, I figured it out, like, holy cow, I think I might be able to make some money and provide for myself doing this. That's when it kind of clicked, like, holy cow, I can connect my passion to, what I'm doing every day.
Yeah, sure. Let's talk about the tuning side of things, because obviously there's a variety of options that are available when it comes to learning about the mechanical elements, becoming a mechanic, if that's the path you want to go down. Less so in the tuning side of things. There's really no formal qualification path that you can take that makes you a tuner. So most people sort of struggle to find that information. I'm interested to sort of learn a little bit more about how you got involved in that side of the automotive industry.
Sure. So, I mean, when you need to know something, if you figure it out, you can find the information somewhere. I did take like EFI 101 classes, but that only takes you so far. So, it just came down to kind of teaching yourself. If I needed something for my car, I teach myself, prove it, and then I could do it on my buddies' cars or my customer cars. As far as a lot of people think, a mechanic is completely separate from a tuner. And in my mind, to be a good tuner, you have to know the mechanics, and you have to be a good mechanic as well. So the fact that I kind of had the mechanic background and then was able to add the tuning to it. A lot of times when you run into an issue tuning, you can trace that back to something mechanical very quickly if you have that mechanical background, to where if you're just a tuner or just a mechanic, you might have a little bit of a disconnect there. So I think that's kind of what has helped me, really be successful, basically.
Yeah, I mean, I've said this half a dozen times or so already on the podcast, but I couldn't agree more with that. I think a lot of people getting into tuning these days, they don't have that mechanical knowledge. And I wouldn't say you have to be a master tech in order to become a tuner, but I absolutely agree. Having a basic grasp of the fundamentals of what's going on mechanically with the engine, the different systems, the fuel system, the ignition system, because as we know, you put a car on the dyno, and 1 in 5 times probably it goes on the dyno, you tune it, there's no issues, and it leaves again. And the other 4 times there's some level of issue that you've got to go through and fault find between minor and something major and catastrophic. So having that mechanical knowledge means that you're not sitting there in the driver's seat bashing the keyboard trying to fix a broken spark plug or a blocked injector, for example. So you absolutely agree with that. Now, at this time, when you're just sort of getting started, what was the platform you were dealing with back then?
So I originally, I told you that story about my brother's car, right? So I ended up getting a Dodge Daytona Shelby for myself when I had to be 16 years old, like just after getting my license. So I was messing with that. I ended up doing like a Force Performance turbo upgrade on that car. Did a lot of really barbaric tuning things to it because you had to, we had like a map sensor clamp on it. What else? Just like, bigger injectors with messing with the fuel pressure, just, basically messing with that car. That's kind of where I started. And, that was in the garage at home with my dad. And he was always yelling at me about shouldn't be touching that car, shouldn't be messing with it. Why are you always messing with your car? Later on in life, he kind of said, I kind of screwed up trying to keep you away from that stuff because look what you've turned it into. So, once I moved on from the Dodge Daytona days, I got a 2G Talon, which is not the car that I have now. I've actually had 3 different Talons along the way, but my buddies, a huge group of friends, they were street racing their cars. They had a Galant VR4 that was out like destroying everything. So that was kind of like, our little group. We had DSMs and Galant VR4s, and this was kind of before Evos were out really doing anything.
Hmm. I'm interested because that's sort of the time when I was coming through getting interested in learning about tuning, and when I decided I wanted to go drag racing, because I thought for me as a tuner and an engine builder, that was kind of the ultimate place to show off my skills, if you like. You can cheat a dyno sheet, but you can't cheat an ET in a mile an hour, and that really tells us just about everything we need to know. And I wasn't really set on any particular platform. I was pretty analytical about it. I kind of looked at the options and I thought, hey, you know what, 4-wheel drive seems to be a good way of going. In hindsight, maybe arguably not, but that's what I had my heart set on. And then I simply looked at the options around, which at the time we never got the DSMs in New Zealand, but we were lucky enough that Japanese imports were pretty prevalent. So we had the Galant VR4, we were starting to get the Evo 1, 2s and 3s, obviously the Subaru WRX and STI as well. And I sort of saw a whole bunch of broken drivetrain components in the early Subarus and decided to go the Evo route, which I'm thankful for. And I was also feeding off the likes of John Shepherd's success in the Talon. At the time, he was head and shoulders faster than anyone else. What do you think is, first of all, for those who aren't aware, there's a lot of family resemblance between the likes of the Talon Eclipse, the Galant VR4, and then the Evo 1, 2s and 3s.
Sure.
Everything kind of changed once they went Evo 4 and above. But what do you think it is about that platform that made it so successful as a tuning platform and a drag racing platform?
I think what made it just so successful is you could make it fast, like really easily and really, really cheap. You could put a boost controller on it, you could put an AFC on it, and you could go out and destroy Mustangs. You know what I mean? So you really can't do that with a Mustang unless you're, putting a nitrous kit on it or putting a turbo on it. And back then, you had nitrous guys, but a turbo on a Mustang was pretty rare back then. Maybe not so much now, but just the fact that you're able to do it cheaply and then be able to put the power down, like you were saying, all-wheel drive is just kind of, really, really nice, especially for a street car.
Yeah, I think bang for buck in terms of trying to get more power out of a car, anytime you're starting with a factory turbocharged car, there is almost always a significant amount of headroom left in them. Absolutely. As you say, with relatively minor investment versus, you're trying to get the same sort of gains, maybe a 20% gain in power out of a naturally aspirated engine. That is difficult and quite often impossible. In terms of the drivetrain, as you said, it's a good basis, but at some point, of course, like everything, we start running into weaknesses and failures. Sort of where did those sort of lie at those times? Or were you below the power level where that was an issue?
So, drivetrain problems in a DSM? Are you kidding me? But once you fix all the weak links, you can make them pretty reliable. But, back then you got to learn all those lessons first. So, I would say it was probably the center diff. The little 2-spider center diff, I would break those all the time. Then you'd upgrade to a 4-spider center diff, right? And then you were good for a while. And then you'd be breaking the T-case output shafts, which is that tiny little shaft that went to the drive shaft. So those were probably the two main things that you just couldn't get around. And, getting a 4-spider back in the day was pretty expensive. And when you're a college student, you're really not spending money on a 4-spider diff. So you just slap another 2-spider diff in there and break it again, right?
Or hit it with the MIG, right?
Yeah.
Not the most sensible option for a street-driven car. So at what point did you sort of get serious about this and sort of start hitting the drag strip and start to sort of chase some times with these cars?
So long story short, I was a full-time karate instructor, and I was working with my group of friends at the time. We were racing these cars here and there, and an opportunity was brought up to where I could kind of shadow a guy in a fabrication shop that was real close to my other job. So I would finish the teaching karate job, or it was before I'd go and teach karate, and I'd go over there and just kind of shadow this guy. He was mainly a fabricator. I also did a bunch of the welding classes at College of DuPage as well. So I had a little bit of a background in fabrication and stuff. So just working under him, he would have people come in the shop, and then we were able to network with those people. And somebody that walked in the shop kind of saw what I was doing, and he had a position open at his shop, which happened to specialize in DSMs and Evos and Subarus. So I took that position, and the rest is kind of history. Hit the ground running, and that was that.
All right, well, let's fast forward a little bit and get some details on the Red Demon.
Sure.
So at the time we're recording this, I believe you've gone 697 at 213 mile an hour. So
yes, sir.
Fastest 4-wheel drive 4-cylinder, if I'm correct, in the world.
Yes. Yep.
And certainly fastest Mitsubishi as well. Obviously, it's a reasonably long path to get there. You're not going to do that overnight, but I'm interested to sort of find out a little bit more about what makes this car as fast as it is. And this obviously starts with the engine. Now, before we started recording, we did talk a little bit about the fact that you are now on a billet block, and we always get the conversational questions about billet versus cast, but I know that this car went exceptionally quick on a cast factory block. So at what sort of point did the cast block become a reliability issue and you decide to move billet?
Sure. I would say, if I had to put a horsepower rating on it, maybe about the 1200 horsepower range is where we started to run into issues. And
we're talking 1200 wheel?
Yeah, 1200 wheel. It was approaching 200 mile an hour trap speeds with the car. So I was in the 190s. And basically one of the issues was, at first I just started splitting blocks. I mean, like catastrophically, I'd split them in the deck, or I'd split them, right in the center, and just like some really, really catastrophic failures. And then we realized that the main studs were loosening up.
Okay.
So basically to remedy that, we would make, 2 passes maybe, and then you're pulling the oil pan, and then you're retorquing the mains, and they'd be loose every single time. You'd retorque the mains, you'd put the oil pan back up, try doing that in between rounds is just not fun, So we figured out a way to make the stock block last, but it just came down to the fact that, I don't want to be on my back every 2 passes pulling the oil pan. It's just not a good time at the track when you're trying to hang out with your buddies.
No. I mean, no one wants to be sort of working on the car constantly all day at the drag strip. I mean, I think the other thing that people can very easily overlook is the safety element of this. I mean, here in New Zealand, and I'm assuming likewise in the US, we have to run a nappy essentially around the engine block. Mm-hmm. The idea behind it is if there is a catastrophic failure, it's going to catch the oil and debris and stop it getting under the tyres. But I mean, of course, that's not bulletproof. And if you are running 200 mile an hour and you get oil under the tyres, doesn't take a rocket scientist to figure out that's not going to end well. So is that another element that was on your mind?
To be honest with you, I think it probably should have been, but no, it really wasn't. I mean, believe it or not, the diaper catches a lot of it. And I've never had an issue where I've had a problem with an engine, even through the catastrophic failures I had with the cast block, to where oil was on my tires or anything like that. Not saying that it can't happen. I mean, I'm sure it does, it does to a lot of people, but, I was lucky enough to...
I had a bit of a wake-up call with my old Evo 3. It was probably, at the time, running high 8s or low 9s, and I was on a pass, and the car that I was racing, fortunately, was quite a bit slower. I got to half track, I was in the right lane, and with absolutely no warning, the car just moved hard left right in front of the car in the other lane. And I managed to pull the chute and sort of get out of it, and had at that time no idea. I thought I'd broken an axle or something like that. And what had actually happened, because everything's solid mounted in my car, the remote mounted oil filter, which in hindsight should have been lock wired and wasn't, that had actually worked itself slightly loose, just enough that it was spraying oil out, obviously under 70-80 psi, enough that some of it got under the tyre on the left hand side of the car, and that was enough. So I mean, at that time, again, a bit of a wake up. If I'd been in the left lane, I'd have been straight into the wall. I'd have just been a passenger, 150 mile an hour. Alternatively, if the car had been faster, I'd have been straight into the side of another car. So these are the sort of things that, initially we start drag racing, safety maybe isn't sort of something that's forefront of your mind, but as I got older and went faster, I certainly started worrying a little bit more about it. Now, in terms of that cast block, just I want to continue down that path for a moment, because a lot of our listeners will be running cast blocks. When you're sort of running that 1200 wheel horsepower there or thereabouts, 190 plus mile an hour, safe to assume on methanol fuel you're solid filling the block?
Yeah, 100%.
So for those who maybe haven't heard that term, can you just explain what we're actually meaning by solid filling?
Sure. So you're filling the coolant passageways in the block with a hard substance. Some people use different things. We just usually use like a Moroso block fill. So it's essentially just concrete that you're basically filling the block with. It adds rigidity, it adds some weight, but the theory is that you're, instead of all those open cavities behind the cylinder walls, it's now filled and supported. So that, essentially is how a lot of people squeeze, a lot more than a stock block is capable of being open or wet with coolant going through it. So.
And I think most people looking at a factory block sitting on a workbench, it's obviously it's pretty stiff, seems pretty rigid, but sure. The reality is when you're running the cylinder pressures that you're seeing to make 1200 wheel horsepower, that's a huge amount of pressure. So it's causing all of the components to flex, which probably sort of comes down to what you were saying about your main studs working their way loose.
Sure.
And that bore flex, of course, does affect the ring seal. So it's not just a case of maybe the bores splitting from excessive boost pressure, but even if they don't split, that reduction in bore seal can affect the power. I'm interested, have you ever done an experiment back to back with a similar combination, same sort of boost pressure, a cast block that's solid filled versus a billet block? Is the power to be had just in the billet block and the superior ring seal that it technically should be able to provide?
I haven't done a back-to-back test. I'm sure that'd be a great test to do, but I can tell you that for sure the car is going to make more power on a billet block. I mean, I saw it right when I switched to a billet block. There was a lot less in my catch can. Every single pass, it was half of what I used to have in the catch can. And the only explanation for that is going to be the compression that's getting past the ring seal, basically. So why am I getting better ring seal in a billet block? I'm using the same pistons, the same piston rings. It's because you don't have that flex like you were talking about. And we see that a lot with, not so much for whatever reason in like the later generation 7-bolt DSM blocks, or, as you guys would, up to Evo 3, we don't see a lot of flex, but in the Evo 8 and Evo 9 blocks, we get it all the time to where freeze plugs are blowing out of these blocks on cars that are making, 800 plus horsepower. All the time it's happening. I think that's a, in direct correlation to what you were talking about with the block flex. It's moving around enough. And a lot of times you'll pop a freeze plug and it's because you're creating, you maybe have a bad head gasket seal or something and you're pressurizing the coolant. But in this case, we could have coolant pressure sensors on the car and verify that, hey, there's no excessive coolant pressure, and we'd still be popping out these freeze plugs. So
yeah, I mean, that's a pretty solid indication that everything's flexing. And I mean, it's understandable, really. Again, comes down to what you're saying about the main studs as well. Everything's sort of flexing there too.
And since then, actually, back then I called ARP. I tried to get different main studs. I tried to see if there was something else from another platform we could steal. Since then, we actually offer now an L19 main stud kit that you can torque up a little bit higher, and it doesn't detorque. And we have, customers going 7s with their cars on cast blocks now without issue. And I know for a fact that block would be split in half if it wasn't for those main studs.
And interestingly, we always found with my engine that when you'd pulled it apart for inspection, there'd always be pretty severe signs of fretting between in the Evo 3 block. It's a 7-bolt block and it's a one-piece cradle, and where that cradle sort of clamps down on the block mating surface, there's always signs of fretting. And what that means is that there's relative movement, and essentially the cradle is actually flexing off the block and moving under the cylinder pressure that the engine's seeing at high RPM as well. And over the course of time, that fretting gets bad enough that you can end up having to scrap a block. So we were sort of going through our own attempts to fix that. And at the time, off-the-shelf L19 or custom-made 625 products weren't really available like they are today. And I forget the specifics, but we actually tried drilling and tapping the main studs, the holes in the block for a larger oversized main stud. And we tried that, and I think I did half a pass down the drag strip, and I got an oil pressure warning come on. So that's weird. So I backed off it, and at the end of the strip, there was a bit of a knocking noise, which is obviously never a good sign. So we shut it down and got it back to the pits and had a look, and there was a dent on the inside of the sump coming out, which is also never really a good sign. Anyway, we obviously pulled the pin on that. When I stripped it down, what had actually happened is that it split through about 4 of the journals where we're drilled and tapped for that larger stud. So we'd sort of potentially fixed one problem and created another. What it actually did was it split through the block, and that dent on the inside of the sump, it had actually made the balance shaft bearing was no longer tight. That was loose. That had fallen out, got crunched up by the crankshaft, and sort of spat into the inside of the sump. So we went back to the stock ARP off the shelf stud at that point. But like I say, there was no better materials available at the time in the stock size. So that was a bit of a limitation. Obviously, you go billet, all of those problems go away because these billet blocks are typically a 4-bolt main. Is that correct?
It is. It's a 4-bolt main, except the outsides were just based on the geometry, there's just not space for it. But
yeah, okay. All right, before we jump into billet blocks, let's talk a little bit about head sealing, because this was always the sort of fuse I found with how much power we could make. Sounds like we probably weren't too far away from you. On my old Dynapack, we were, I think, 1166 wheel horsepower to about 55 psi. But at that point, head gasket integrity really became the limiting factor.
Sure.
What did you find worked, and what are you using today, if we can dive into that?
Yeah, so I mean, I've tried it all. We've tried the different MLSs. We've tried, O-ring in the block, O-ring in the head, copper O-ring in the block, copper O-ring in the head. We've tried it all. So, if you're running anything up to, 40, 45 pounds, an MLS works great. Anything over that, if you want to keep, coolant passageways or like a wet deck where you actually have coolant going from the block to the head, you got to use a fire ring head gasket setup. So those work great. For my application in the Red Demon, I haven't changed it to a fire ring setup just because what we have works really, really good. So I just haven't messed with it. We just do an O-ring in the head, a receiver groove in the block, and it's a copper head gasket.
So that's essentially a top fuel or top alcohol style sealing technique as well.
Sure.
That's what they use, correct?
Yep.
And the idea behind it is that the O-ring deforms that relatively soft copper head gasket into the receiver groove, and that way it locks it in, so you've got that combustion pressure really just can't get out.
That's what I used to kind of think. You've got like a higher pressure area maybe, but I don't think the copper really holds the pressure like that. I've got a really good machine shop that we use, and he does a lot of like pro stock engines, and he'll be on the dyno for sometimes, weeks with one engine, just trying to squeeze whatever horsepower out of it. And he ends up rebuilding a bunch of times. Basically the theory that he told me behind why it works so well is because the O-ring and the receiver groove are displacing the head gasket and keeping it from moving like laterally side to side.
Yep, that makes sense.
And, the sealing is still done on the horizontal surfaces that are clamped together. But the fact that the head gasket can't slide side to side at all and it's locked in position, it allows the clamping forces to seal to where they wouldn't seal normally if it's moving.
Yeah, in terms of the firing, you used that term just before, and I hear the term firing used to reference a number of different styles of, firing.
Sure.
From something with a spike on it, like a stainless steel ring with a spike on it that actually cuts into the cylinder head, to these days a lot of people are using the aluminium bronze, or I call them sealing rings, that go between the block and the cylinder head. And then of course there's gas filled O-rings. There's a number of different styles that people refer to as firing. So can you talk to us a bit more about what you mean by that term?
Yeah, so I have experience with a couple different types of those. On our MK5 Supra, it looks like a stainless ring, and it has like two grooves on the top of it that basically cut into the cylinder head. And that's worked really, really well. There's no locating groove or anything in the block. The ring basically just locates in the head gasket. That works really, really well in that it's a BMW B58 platform. The ones that I've used on 4Gs are supplied by Bullet, and it's basically like an L-shaped ring where you cut a groove into the block, and that groove basically locates the ring.
Yep.
So it can't move side to side. And then you've got the copper gasket that ends up being probably, 3 to 5 thousandths thinner than the sealing ring. So when you torque down the head, it preloads that sealing ring around the combustion chamber.
Yep.
Those work really, really well as well. As far as like the gas-filled rings, I think I tried one of those way back in the day. It didn't work for me very well. I want to say Cometic just came out with something for the 4G application that works really well. It's like a fire lock head gasket. And it's the same kind of thing where the gasket kind of locates the ring. And, those rings are preloaded really, really good, and they end up biting into the head to where, like when you take the head off, you can see literally the impression that it leaves. And, that's just the compression being sealed. And
Sure.
That's how you get away with, 50, 60, 70 pounds of boost with a wet deck.
Yep.
Still able to flow coolant.
There's a problem with a wet deck, or even if you are running a solid filled block, so you don't have the issue of water transfer between the head and the block. You still have oil regardless, and depending whether the head's been welded up in terms of the coolant ports, you will still have water sitting in the cylinder head. And copper does a horrible job of sealing oil and water, correct?
Yeah. When we do use those fire ring applications, so you've got the ring that seals the compression and then the copper gasket, we end up just basically applying like a thin layer of RTV sealant to it. And we actually do it with, like a paint roller. So it's real nice and even. So you can get like a real nice even coat on both sides of the copper. And then that copper will seal real good with the RTV on it for coolant. But
Sure.
Obviously you're not sealing any compression with that.
Yep, yep. All right, let's talk about the different engine combinations, because in the Mitsubishi world, there's numerous, and everyone sort of seems to have their own ideas on what's the best combination. There's obviously, to start with, the 4G63 and the 4G64, which is a 2.4 block, which is 6 millimeters taller in the deck surface and uses a stroker crankshaft and a larger bore diameter. And then there's other combinations using the 64 block with a 63 crank. There's 88, 94, 100 mil stroke. The list goes on. So let's narrow it down. What's been your go-to combination? What have you found works really well at the drag strip?
So we use a 4G63 block and an 88 millimeter stroke crank.
So just a stock 2 liter, essentially.
Essentially, yeah. We're changing the rod ratio a little bit because we go to a 156 rod. But other than that, just 4G63 block, 4G63 crank.
Okay. Talking about that rod to stroke ratio, so you've mentioned you've made that, or improved that, made it longer. How do you go about doing that when you're dealing with a stock crankshaft and a stock block?
So you're somewhat limited by the stroke of the crank and the height of the deck. So the only way to do that is basically you change the rod and the piston together. So you can move the wrist pin location 6 millimeter up in the piston, and you make the rod 6 millimeter longer.
Yep.
So essentially you're changing the ratio is like, the length between the stroke and the length of the rod.
Sure. And the theory here is this improves the engine performance, particularly as we start going higher and higher in the RPM, correct?
Yeah, that's the theory behind it. So like if you think about it, the rod is at like a less of an angle as it's transferring power to the crankshaft. Just based on physics, you have like a more efficient design when you're not at that huge angle. It also helps with, like side loading the piston, stuff like that. So when we were pushing the factory blocks, we actually noticed like an increase in reliability when we went to that long rod setup, when we were having those issues with, getting the stock blocks to live. It seemed like they liked the long rod setup a lot better than they did a regular 150 millimeter rod.
In terms of this as well, in the Mitsubishi world, this is actually not a particularly uncommon modification, because an early modification that was really popular was to put the 100 millimeter stroke crankshaft from the 64 into the 4G63 block, and then of course if you don't do anything else, the piston comes out the top of the block at top dead center. Obviously that's not going to work, so a lot of piston manufacturers made a specific stroker piston for the 63 block, where the wrist pin had been moved up in the piston, as you say. Now, one of the elements with that is you sort of end up with that wrist pin intersecting through the oil control ring. Obviously not the whole way through, but are there any downsides to do that? Normally you need an oil ring rail support at the bottom, because you have essentially a gap now at each side of the piston to allow that wrist pin to be installed and removed.
It's not ideal, but I mean, you've got that bottom ring support. We have a custom piston that we do, and it comes with a bottom ring support, and we don't see any issues with the oil ring or, burning oil or anything like that. So I don't think it weakens the setup in any way. We recently have redesigned our pistons again with a 24 millimeter pin, and it's going to start intersecting with the top ringland on the oil ring. So we actually had to make a decision on how far to basically move the rings up. So we made some decisions on that and added like an accumulator groove between the top and the second ring, and did some other things. But, we're at the point now to where, the factory Evo stuff is 22 millimeter pins. We've gone to a 23 millimeter pin, and we're still, in probably 12 to 15 passes, the rods are garbage. The small end of the rod is just an oval, and you can just bang the wrist pin around. So
I think it's actually worth focusing on that for a moment as well, because I know a lot of people probably, reading articles about cars like yours on the internet and, watching on YouTube would think, well, you buy the best parts available, put them in, take this engine that used to make 300 horsepower off the showroom floor, we'll wind it up to 1,500 or 2,000 horsepower, and that's going to be fine, and we'll get, a season of drag racing or 100,000 miles of trouble-free motoring out of it. And the reality, of course, is that's just impossible. We're trying to do something that these factory components were never supposed to do. So I think bringing a highlight to the fact that these internals now essentially become somewhat consumable, right?
Yeah, pretty much. The rod, as far as like how long it should last, it should. I mean, it's not like it's at the, you could probably get 50 or 60 passes out of a rod easily, no problem. But the fact is, like, mechanically, you can take the pin and like move it in the top of the rod. I'm not going to run that, So
it's essentially flogged out the small end of the rod.
Exactly. Yep. So like as soon as we start seeing some play there, we cycle them out, and like I said, I mean, sometimes it's 12 passes only on a set of rods, which you can do that pretty quick.
All right, safe to assume here you're also using alloy rods, not steel?
Yeah, definitely.
So obviously, that when you go to an alloy rod, there's pros and cons. We'll dive into that. One of the downsides is that the alloy rod does have a fatigue life on it, and as you mentioned there, other than the small end of the rod maybe becoming oval and having that play, the rod might do 50 or 60 passes depending on power levels, RPM, and a bunch of other elements in there. So unlike a steel rod, which within reason, if you're under the ultimate strength of the rod, should basically last forever. So where are the advantages in going to that alloy rod, and why are they so prevalent in a drag racing engine?
Well, I mean, weight is one of them, right? So you're taking weight off of the rotating assembly. Another one would be, it's got a little bit of give to it versus steel rod. So it's kind of like a little mini shock absorber in your engine. It's kind of taking up a little bit of the harmonics, maybe a little bit of the sharp, hard hitting power, and it just got a little bit of give to it. So I would say the two biggest things would be the weight and the fact that, it's got a little bit of give. An aluminum rod will bend or tweak long before it'll break, where, if you're running a steel rod and you break a steel rod, I mean, your engine's absolutely destroyed. So, I've had it to where, we take it apart and it'll be tweaked a little bit, or it'll be bent a little bit, or, something will be off. And I know that if I had a steel rod in the engine, it would be completely in pieces at that point, to where, the aluminum rod had a little bit of forgivingness to it, to where, it saved things.
Yeah. And I think, we run these engines on the ragged edge, and it's not uncommon for the engine to maybe experience some momentary knock, detonation, and that shock loading, as you say, the alloy rod can sort of tend to absorb that. Your example of a shock absorber is actually quite a good way of explaining it, whereas a steel rod, there's no given that it's basically going to transfer that shock loading from the knock event straight down the connecting rod and into the big end, and that can actually show up with the big end bearings actually failing or becoming hammered out due to knock, correct?
Yeah, we've seen that before. So it's just, well, we were running a steel rod for a long time. I was actually at a half-mile event in Ocala, and a representative from Manly came up to us because we were running half mile at that time. I think we ran like 2:13 at that event in the half mile, and that was pretty good for back then. It was probably 8 years ago or something like that. And he was shocked to know that we were running his Manly steel rod in the car. He said that we were far surpassing what the rod was designed for, and he was actually like kind of like, it almost seemed like he was worried about me.
That's always reassuring.
Yeah, right. But yeah, I mean, we never had any failures with the Manly rod, but we would definitely, beat up bearings a lot more than we do with the aluminum rods.
Sure. All right, well, let's move on a little bit to the billet block. So there's a lot of differences, obviously, between building the cast iron block and building out something in billet. Obviously, the billet engines also have the option for cooling passages through them if you're street driving, or a solid filled solid. It's not filled, it's just a solid billet for drag racing applications. I take it, yeah, you've gone the solid billet route?
Yeah, we have a solid billet block. There's no coolant passageways in the block. There's no need for it. I mean, we run the car, 5-10 minutes at a time at most, like warming it up or something like that. So we don't need the coolant. The added strength, getting rid of the passageways, is the way to go in our application for sure.
In terms of the actual building process, what are the differences that you need to keep in mind when you're building up a billet block versus cast iron? What do you need to focus on?
So there's a bunch of little things when you get the billet block. I mean, some of the major things are, when you size the mains in a stock block that's, made out of cast iron, you size it differently than you do in an aluminum block, knowing that the aluminum is going to grow once it heats up. So that even, and then we'll even set it up differently if it's a drag racing motor, like, a car, like the motor in the Red Demon, we'll set up a little bit differently than, say, a billet engine that's going to be street driven or road race, knowing that it's going to get really, really hot, knowing that those mains are going to grow. So that's one of the main things you got to look into. Another thing is, just all the little fine details I've learned along the way. The rear main on the billet blocks don't drain properly because of just the way they have the block machined and stuff like that. So we do a couple things to get the rear main seal to drain properly. Even sizing the pistons, the piston to the piston wall is a little bit different on an aluminum block versus the cast factory block.
Okay. Just coming back to the bearings, you're talking about the clearance here and sort of reading between the lines, the block grows,
Sure.
which we'd expect being alloy, higher thermal coefficient of expansion than a cast iron material. So you're essentially setting the static clearance in the workshop tighter than what you would for a factory cast iron block.
Yeah, so the factory cast iron block, you can kind of set it where you want it to be when it's living. It'll change a little bit, but with the aluminum block, knowing that growth is going to be there in the bore size and not in the crankshaft, you have to account for that. So you actually do set it up, ends up being pretty tight when the motor is cold, knowing that it's going to grow and it's going to be right perfect by the time you're at operating temperature and that bore size has grown a little bit. Then your bearing tolerance will be perfect at operating temperature, which is really the target. You don't really care what the bearing tolerance is when it's 70 or 80 degrees sitting in your shop. You care what it is when, you have your oil temp at 150 or whatever it's normally going to be at,
Yeah,
So.
yeah, absolutely. Can we get a sense of what that difference is? Let's just stick to drag racing for a moment. Just it doesn't really matter, but I mean, are we talking like a difference of a thousandth of an inch, or half a thou, or what sort of range are we in terms of how much tighter we go with the billet block?
Yeah, so in my application for drag racing, we usually go about a thousandth tighter.
Okay, that's significant.
A significant amount. In some of the other stuff, like we just did one for a customer, it's a wet block. So, there's going to be, 180, maybe 200 degree coolant flowing through it. He road races the car. We actually set it up, even a little bit tighter than that, knowing that it's going to grow a bunch. We want it to be happy in its operating range. So, I mean, it's not just a half a thousandth. It's a,
that's a lot.
And my machine shop actually, measures the bores. He did this at first. He doesn't do this on every block now because we know, but he measured the bore, in a 70 degree, assembly room. And then he heated it up to 180 degrees and measured the bore and actually saw the exact change that the block had in bore size. And that's what we've based everything off of.
Yeah, that makes sense. It'll give you the confidence to know that you are on the right track. Now, on that note, though, you're starting, and I mean, we're sort of almost talking similar to the way they deal with the likes of a Formula One engine, where they have to preheat the oil and water because of the clearances being super tight at room temperature. Do you recommend or go down that path of preheating anything with your own engines or these ones you're building for customers, or is it more a case of education for the customer? Allow the thing to come properly up to operating temperature before you exceed X thousand RPM or use any boost. Yeah, obviously,
Sure.
If you sort of just went straight to the rev limiter, 50 pound of boost when the engine's stone cold, that's not probably going to end too well for the bearings, right?
Yeah, exactly. So, I mean, we've had my motor, like, for say, at import versus domestic, and it's, 30 something degrees out and the car's been sitting there all day. So, like, we've started the car, when it's approaching freezing, and, everything is fine. We haven't had any issues with it. So, do I rev it up right away? No, you put some, warmth, put some heat in the motor first. But that's basically what we'll do is we'll just inform the customer, hey, like, this motor's not going to be happy when it's cold. You got to make sure it's warmed up before you start, revving it or putting power to it. And we've had a really good luck just doing it like that. And it's not set up so close to where, when it's 30 degrees out, the motor's not rotating.
Yeah.
You know what I mean? It's still going to rotate for you, but it's not going to be happy making any sort of power with those oil clearances that are there when the engine's cold.
Yeah, and I think there's a misconception, this urban myth that I continually hear, that a Formula One engine will not turn over by hand when it's cold. And of course, that's not actually the case. Otherwise, they'd be incredibly difficult to build. But they still preheat the oil and water to get everything up to that operating temperature so the clearances are where they should be. So could you start one when it was absolutely stone cold? Maybe, but it's probably not going to be very good for the engine. So similar to what you're saying. I just mentioned as well for those who are maybe wondering a little bit more about the preheating side of things, a really interesting product I actually saw at World Time Attack earlier this year. One of the GTR race cars there that used a billet block, they're actually using a preheater for the water, and it was quite a nice system. They had two dry brake fittings that the heater went into as a P1 product, I think, and it incorporated a heater and a little pump all in the same unit. So they plugged that in for 45 minutes and it got the coolant temperature up to, it wasn't full operating temperature, but in degrees C, probably got up to about 70 C. So at least before they started up, it was sort of ready to go, particularly in those applications. You know, the car's not out there for 15 minutes. It does an out lap, one flying lap, and the job's done. You know, not too dissimilar though to your running there, where you can't sort of run the engine for a long time. We've already talked about the fact you don't have coolant in the block. You've got coolant in the cylinder head. You're running on methanol fuel, which is sort of one of the reasons you can get away with that. It's got a great cooling properties. But is that a consideration for you in a drag racing application, getting enough heat into the block before you actually go into stage for a run?
Yeah, absolutely. I mean, you got to have some, oil temperature. So, you don't want cold oil. So the oil temperature in my mind kind of represents the block temperature. So we try and start the car up, get it warmed up, 120, 130 degree oil temperature, and then we'll shut it off just to, know that there's heat in the engine. And we'll never try and run it cold. That's just, it's not going to make good power. The oil's too thick, it's just not going to be smart to run cold. So we always are making sure that, we're running it, at least, 45 minutes, something before we plan on running. Sometimes it'll sit there longer, but, starting it and keeping heat in the engine before we try and make any sort of power is very important.
Okay. Right, let's move on to the cylinder head. Essentially, the block is really there primarily just to support the power or the cylinder pressure. The head and then the turbocharger, of course, as well. Those are sort of the elements that really make the difference in terms of how much power we're able to make. I just wanted to interrupt our podcast for a moment, and if you are enjoying this chat about 4G63s and you want to learn more about building performance engines, then we've got a course that is going to be perfect for you. This is our practical engine building course. The course itself is generic, so even if you're building a 2JZ, an LS2, or basically anything else, the course will teach you everything you need to know about building a quality, reliable engine. You'll learn all of the elements that you need to understand in order to deal with a machinist, get the right results. You're going to understand how to specify your clearances and the tolerances inside your engine to suit your specific application. I know that when it comes to building your first engine, it can be a bit daunting knowing what to do first and what order to progress in. And what we've done within this course is broken the engine building process down into a 10-step process. By doing this, each of the individual steps of that process is relatively quick and easy to complete. And by the time you get to the end, you're going to have the confidence that your engine is built correctly, all of the clearances are correct, and you're going to have the confidence that when it comes to starting that engine for the first time, it's going to work exactly as you'd expect, giving great power, great torque, and great reliability. Now, as I mentioned, the course itself is generic, but we also have a library of worked examples, which is where you get to watch that 10-step process being applied in real time on a real engine building job. Here, we vary the type of engine that we are building, and for the 4G63 buffs in there is a full worked example where we go through the process of building our very own 2.2 litre stroker engine for one of our in-house cars. This course also comes with a 60-day no questions asked money back guarantee, so if you purchase and decide it's not quite what you expected, no problem, let us know and we'll give you a full refund of the purchase price. And remember, you can use that coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. Again, we'll put a link to this course and that coupon code in the description. All right, let's get back to our interview now. In the 4G63 world, there's the early big port head, and then there's the later, I call them the Evo head, the small port head. On face value, looking at the big port head, bigger's better, right? But that's not always as simple. So what's the pros and cons of big port versus small port? What's the one to go for if you want to make a lot of power?
In my opinion and in my experience, the lower power cars always like the smaller port head. You get a little more velocity going. So, if you have a 600, 500 horsepower car, it's going to love that small port head. It's going to be great. Even making more power than that, it's fine. When I noticed, the reason to go to the big port cylinder head is when I went to methanol and then I started spraying a bunch of methanol. It's just there's a lot of volume taken up just by the fuel alone that you want to make sure that the air can get there. And when you've got that small port and you're stuffing that much methanol in there, you want to make sure everything's got enough room. So that was kind of my thinking behind the fact of going to the big port head. I did run a small port head for a long time. You got that whole velocity versus speed.
Yeah, I mean, I'm definitely not a head porting specialist. I'm sort of on the fringes of that. I talk to people who are, but I mean, there is it's a bit of, I kind of see it as almost a mix between an art and a science, but that balance between airflow and air velocity is so important, particularly for the low RPM response, albeit obviously in a drag application we care less about what's happening at 3,000 and 4,000 RPM. We still need some boost response to actually get the engine to work how we want, but generally the engine's only going to be running over a fairly narrow rev range right up the top, which sort of changes some of our requirements there. Now, another element with the 4G63 head is that in stock form it uses a hydraulic lifter, which is great for low maintenance, albeit obviously as they get a bit older, the ticking lifter in the 4G63 is a pretty common thing. Not really that suitable though for a drag application, particularly with really aggressive cams, two-step launch control, etc. What are the problems with the hydraulic lifter, and what was your solution to that?
There are definitely some issues with the hydraulic lifter. I tried the solid lifter, and just because I was having issues with we'd set lash and the lash would move, the lash would change, and then you're constantly setting lash and constantly checking the lash. It just turned into a whole ordeal that I just don't want to deal with at the drag strip. So we ended up going back to a hydraulic lifter, and there's a couple different things that we do. There's a company that sells a regulator that goes on the head that regulates the oil going to the lifter, which keeps more oil in the bottom end. We actually don't use that. So we want to try and get as much oil to the lifter as possible. I make sure there's an oil passageway that goes through the head stud hole that feeds the head. So we make sure we kind of open that up, make sure plenty of oil can get through there. The main thing that I figured out that helped a lot with, a lot of people having issues with breaking the rocker arms or throwing the rocker arms off. We basically shim the lifters. We shim the bottom of the lifter up, so it doesn't have to expand a bunch to get rid of the lash.
Okay.
So normally, if you set a stock valve, stem tip height, and you put the lifter in there, it's expanding quite a bit to get rid of all the lash. So what we do is we basically shim underneath the lifter, so it basically doesn't have to expand all that much. And even in the worst case scenario, say that lifter, got bled down, there's not going to be a ton of slack in there to where hopefully the rocker arm doesn't fly off.
Sure.
So that's kind of the biggest thing that we've done is we shim the lifters to where the hydraulic lifter really isn't doing all that much.
Yeah, okay, that makes sense. I mean, I totally agree that setting the lash on those heads when you go to a solid conversion is an absolute ball ache.
Yeah.
We were using, I think it disappeared off the market, and I probably understand why. At one point we were using a special solid version of the hydraulic lifter, and it had a little locking nut on it, and you could sort of get in there awkwardly.
Yep.
Back it off and then unscrew it and set your lash that way and then lock it up, and they just work their way loose in operation every damn time. So we went away from that and basically made up a solid insert to go inside the factory hydraulic lifter, which was rock solid, but still you have to shim them. One of the problems, well, there's two problems as I see it with the hydraulic lifter. One is the potential for them to pump up at higher RPM, albeit I never really saw that as such an issue in the 4G63 is definitely a problem with some engines that run hydraulic lifters. But the other one, which is more prevalent with drag racing, is that sometimes they can end up pumping up on the two-step limiter. If you're really aggressive on that, you can end up with those pressure pulsations essentially popping the exhaust valves back off their seat when they should be closed, and that allows the lifter to pump up. I mean, obviously you're not having issues with that, but how do you get around that? Give us some insight.
And we've never run into that issue with the 4G application with actually the lifter pumping up too far to where the valve doesn't close. Is that what you're saying?
Yeah, correct. So you see it, well, I have witnessed this on a two-step limiter, and basically, you've got a lot of ignition retard and ignition cut, so the fuel and air is essentially combusting in the exhaust, and it would do what you'd expect. You'd make boost sitting there, maybe 7,000 RPM or whatever your two-step limiter is set at, and then you'd back off it, come back to idle, and the engine would idle on 2 cylinders and sound horrible for 30 seconds, 45 seconds, and then it would come right again.
You know what? You're refreshing my memory, because I actually had that happen at Shootout a couple of years ago with one of my customers, and it was the exact same thing that you said. He was on the launch control, and then after he'd get off the launch control and come back to idle, it'd be missing. So we actually tracked it down to the valve stem tip heights not being correct.
Okay.
So the heat or whatever he was putting in the valve would expand enough to where it was taking up that little bit of lash that was there, and then the valve wasn't closing all the way. And the way we remedied that, we actually did it at the track, is we took the lifter. First of all, we figured out what cylinder it was doing it on and all that. And then we took the lifter out and actually ground the bottom of the lifter down, the opposite of what we do, like shim them up to where it set the lifter back down to where it had lash once it warmed up.
Okay.
Because I've never had it to where the lifter will out pump like the valve spring or something like that.
Sure.
But we have seen to where, like the tip heights aren't correct and that lifter is all the way collapsed. And then once everything warms up, it has, the valve essentially can't close.
Yep. Yeah, that makes sense. Okay. Now, obviously, we've talked about the cylinder head and the block, and I mentioned the turbocharger, and this is something that I've kind of seen over the last 5 years, maybe the last decade. We've seen massive advances in turbo technology, which is, I think, made it so much easier for people to make huge amounts of power, and also huge amounts of power without the sort of sacrifice and boost response. Can we start with maybe what sort of turbo are you running on the Red Demon, and how's the development of your turbo side of things sort of progressed?
Yeah, so there's a fine line when it comes to a stick shift car, a stick shift 4-cylinder car that's making that kind of power. So I ran into the issue to where, we want more power, but we started going to the bigger turbo, and then our ET and the short track was suffering because of it, because we didn't have that transient response in between shifts. So it's been a balancing act of trying different turbos, trying different stuff. And basically the biggest thing that we saw that helps with that is just the way the shift cut is set up. So you can actually, have some anti-lag during the shift cut that keeps the boost up, and that has allowed us to run maybe a little bit bigger turbocharger than we could have if we hadn't enabled that type of strategy during the shift cut.
Just talking about that shift, and I wanted to get into this in a moment anyway, but you've said you're a stick shift here. Still a dog engagement gearbox, but essentially, unlike a lot of drag racing cars that either run an auto transmission or a proper drag racing only clutchless transmission, this actually requires some kind of torque reduction. Usually we use an ignition cut to actually allow the dogs to release and get into the next gear, correct?
Exactly, yep.
And then even when that shift is really, really fast, these bigger turbos, if you look at the log, you're actually seeing quite a significant drop off in the boost. So that's what you're talking about with that transient response.
Yeah, a drop off in the boost and in both, shaft RPM on the turbocharger.
Sure. One of the changes we're seeing with modern technology and the turbochargers is they've gone a long way to reducing the inertia or rotating mass of the turbine wheels. There's some special materials there. I think as well, in terms of aerodynamics, I think they're managing to get more airflow out of a smaller diameter wheel, which again helps with that inertia. Has that been a game changer with what you're able to do now?
Yeah, Honestly, the turbocharger that's on the Red Demon, it's been the turbocharger that I've had for, probably the past 4 or 5 years.
Okay.
So like that car doesn't have like the latest cutting technology as far as turbochargers are concerned. We're kind of at like a crossroads to where if I want to do anything else, I kind of have to go to like a T5 or a T6 manifold, and the car is on a T4 manifold. So that's kind of been holding me back. It doesn't have the latest and the greatest stuff. It's just we've learned how to manage the power really well, and we've never had a problem needing more power, and I can't even use all the power I have, to be honest with you.
It's a good problem to have.
Yeah, I mean, we can use it in fourth gear, but that's about it.
Yeah. Can we know what the actual turbo is, or is that sort of a secret source?
No, it's an 8884. So it's like their big shaft 8884, because I was having issues. I used to run their off the shelf 8685.
Yep.
And it's got a smaller shaft, and I used to break those things all the time. So we went to basically like a larger frame that has a bigger shaft, and it's a custom turbo. It uses an off-the-shelf compressor wheel, 88 millimeter compressor wheel, and then it's their big shaft turbine wheel that they trim down to an 84.
And what we haven't really talked about power levels. I mean, earlier we talked about 1200 wheel horsepower kind of being the point where you moved away from the cast iron block. So let's get some specifics now. Sort of where do you think you're at in terms of power levels? What RPM are you revving the engine to, and what sort of boost pressure are you using to get where you're at?
Sure. So I mean, as far as like the power level is concerned, you can just kind of cross-reference the data from the drag strip, because we don't come anywhere near running it at full power on the dyno. So and then at that, we're only running it at full power for maybe those last couple seconds during the pass. So if I had to guess, like maybe boost only, maybe 1700 horsepower, somewhere in there. And then we usually, depending on the track conditions, we can spray, up to like a 300 shot on top of it.
Okay. So I'm interested to know about the strategy there with the nitrous versus boost only. Is that because you're out of turbocharger, or using the nitrous as a bit of an infill? Yeah, give
Sure.
us your sort of take on that.
So when we were going through different turbocharger sizes and all the different turbocharger changes that I was doing 4 or 5 years ago, we implemented nitrous to basically help with that transient response.
Yep.
So after the gear shift, it might have like a 300 shot on it, but we spray it progressively to where in first gear it only uses 30% of it, and in second gear it'll use 40% of it. So kind of step it up that way, and we're using it to kind of help with that response.
Yeah.
With the turbocharger. Since we got this new 8884, we don't need it for the transient response anymore. So basically what I do is I kind of set it up like on a scramble button. So, to where like I'm not automatically spraying nitrous at the car, because sometimes given the track conditions, or, maybe I'm a little loose on a pass or something, to where like, when I'm dead straight and I hit third gear, if it's feeling good, I'll hit the nitrous. As far as, did we run out of power with the turbocharger? I mean, we're running it at about 90 pounds of boost. I don't think we're out of power. Like I said, I mean, I can't use all the power that I have right now. So we could probably crank it up, 100 pounds, 110 pounds. Who knows? I don't know.
Yeah. I think that's another element that people who aren't involved at that level that you're racing at probably wouldn't understand, is that in most instances, except as you say maybe fourth gear, you're actually able to make more power than you can put to the track at just about any point. So what are you using in terms of torque management there? Is it boost versus speed, boost versus gear, a combination of all of the above?
Yeah, so we're still on a Haltech 2500. They do have like a torque reduction strategy, but it's not the greatest for a manual transmission car, because our drive shaft speed is not as consistent as, say, like an auto car, where you could take like the best run and that drive shaft speed is real consistent. There's a lot of inconsistencies when you're shifting the gears and it's jumping up and down. So to implement that kind of torque strategy, I haven't figured out yet. I tried for a while doing like GPS stuff, with a GPS speed sensor versus the speed sensor on the car, and it ended up not really updating fast enough. So I've tried a couple different things, but the way we do it now is boost based on gear. And then in first gear, I regulate boost based on a race timer. So, it'll let me launch the car, and then it ramps up boost based on, how much time I've been in the pass. And that way, it's not like a steady number through first gear. I can actually build it more or less given the track conditions or, the temperature or whatever.
Another element, one thing I found with my own car, and then we built an Evo 9 that at the time had the world record for the late model Evos. And with that Evo 9 in particular, what we found was the turbo was quite slow to build boost. It was nothing flash. It was an old GT4202, so reasonably old technology now, and it had a lot of inertia. And I think, if my memory serves correct, we were sort of launching that around about 22 PSI, and we're running about 42, 45 in third and fourth gear. And the problem I found is if you left at 22 PSI and then, first gear, it's obviously a bit of wheel spin and you're sort of managing that. And then second gear, it would take more boost. And then third gear, it would take more and then would step it up again. But each time you wanted to increase the boost, it took, you look at the log and it's quite a slow progression to actually get there. It's not a sharp step. So what I ended up doing was purposely running more boost through first and second gear where the car couldn't take it, and then controlling the torque by retarding the ignition timing. There's a balancing act here because the retarded ignition timing creates heat, but what that meant is when I got to third gear where the car would actually hook up and take the power, the boost was already there or thereabouts what I wanted to run. I mean, have you seen anything similar to that?
Yeah, so it's kind of similar to what we do with the GTRs too. So like once you start getting a big turbo on a GTR, it'll hook real good through, say, first gear, but then you go to shift second gear and it bogs down on you. So that's kind of why I implemented the race timer into the boost strategy, because, based on race time, I could, right at the end of first, once the car is already hooked up, already putting the power down, then I lay into it for that exact reason, in anticipation for building up that shaft speed for second gear so it's ready the second you hit the gear.
And of course, what you were talking about before with the nitrous kind of, that can be used as well to overcome what I was just talking about as well, correct?
Yeah, you can, but I mean, I think a better way of doing it is building up that shaft speed. Now, the way you were doing it, just blowing the tire off through first and second, I don't know, but yeah, it definitely had the car ready to go.
Oh no, I take that back. We weren't actually through first gear off the line. There's obviously going to be some wheel spin, otherwise you're going to bog down. So no, I was retarding the timing to keep the car actually hooked up. We weren't wheel spinning through second. We were trying to keep the car hooked up, but using a lot of ignition retard just to keep the boost higher than what the engine would actually take if we were running MBT timing. So that's sort of what I was getting at there.
Oh, gotcha.
In terms of getting these cars off the line, since we've sort of transferred on to talking about that, this is a bit of a kind of a challenge again. It's a bit of walking a tightrope here between getting the car to leave well 60 foot really good and not end up bogging down or lighting up with wheel spin. And I mean, doing this manually by slipping the clutch with your left foot can be quite tricky. I know a lot of four-wheel drive drag cars, the worst kept secret of drag racing was always the hydraulic slipper valve on the clutch. I tried one of those back in the day and found quite good results. Are you using anything like that, or are you just manually slipping the clutch yourself?
Yeah, so I mean, we manually slipped the clutch for years. Up until about maybe 2 years ago, we were manually slipping the clutch, and we had really good results with it. We'd go a good 60 foot, we'd make really nice passes, but it really wasn't that consistent. It was kind of, I mean, it was very consistent for a manual car on what we were doing, but not as consistent as what we wanted to be. So, I even see some of my customers right now, I try and talk them into the slipper, and they do really, really well without it. They can set personal bests without it. But, unless you can convince them that, in the long run, once they put some time into it, it'll be better. It's kind of an uphill battle. But I finally convinced myself that, the slipper was the way to go. And it takes a little bit of a learning curve. And, a lot of things affect it. Clutch wear affects it. The temperature of the fluid affects it. Whether the clutch is, a new clutch, an old clutch. I mean, there's a lot of things you got to take into account. But what we use is a hydraulic clutch slipper.
For those who maybe don't have a clue what we're currently talking about, can you explain what that unit is and how it actually functions?
Sure. So it's a valve that goes in between your master cylinder, your clutch master cylinder, or your clutch pedal, and the slave cylinder. and it basically limits the amount of fluid that can be traveled through it. So basically, when you release your clutch pedal, it's not coming up all at once. It actually regulates it and brings it up slow. And then it's adjustable, so you can have it, come up real slow or a little bit faster or a little bit slower. So it's got that level of adjustment to it. And then the one we use also has a line lock built into it to where you can completely deactivate it. Like when say in second or third gear, say you want to maybe be able to pedal the car or clutch in if you have to, and you want it to work normally, you can disable the slipper, for the rest of the pass, and it's only enabled for like the very, very beginning of the pass, say in first gear.
Without that mechanism, that bypass mechanism you're just talking about, this unit's completely useless for any car that actually needs to use the clutch for the rest of the shifts, correct? It has to essentially be clutchless.
Yeah, exactly. So if I didn't have that line lock and it just stayed on all the time, you wouldn't be able to use a clutch because it would just be constantly slipping. So that would allow you to use that in an application where you want the slip in first, and then when you clutch into shift second, it's nice and firm and fast like it should be.
And again, for those who haven't seen one of these, if you put your foot completely on the clutch, depress it all the way to the floor, and then sidestep it with one of these slipper units active, depending on how you've got the thing tuned, it might take 2 or 3 seconds even for the clutch to come all the way back up. So it's just controlling the rate that the clutch engages and allowing that clutch to slip, and then you can tune it to suit. Back when I sort of started using these, I don't actually think there was anything commercially available, and I modified the old Turbo Smart Boost T, the old pneumatic boost control valve that you'd sit in the engine bay, and I put a dash 4AN fitting on the inlet and outlet of that, and that worked well, and I had it down by the driver's seat so I could tweak it to suit. But the problem I had with this, and I don't know if your commercial solution was different, it was great for setting PBs, but it was very difficult to cut a light because you'd sort of get the clutch to the engagement point as close as you could, and then you'd come into stage and you'd be up on the 2-step, and then when the tree came down, you'd sidestep the clutch, but there was always this slow take up. So it's very difficult to cut a really good light and consistently cut them. How does yours have that issue, or how do you get around that?
Yeah, so we noticed the same exact thing, and even with the customers that we tried using the slippers with, we would have the same issue to where like they were just sitting on the line and getting killed reaction time wise. So the way we basically got around that is just setting the clutch engagement point like literally off of the floor. So like you clutch in and you put it in first gear and it almost drags you forward a little bit, to where like, yeah, it's not like ideal, but at least the second the clutch is moving, that it's engaging. And then as you light up the second bulb and you're in the staging, you kind of let the clutch up a little bit already. So you're not taking it straight from the ground. So you're bringing the clutch up a little bit already before you sidestep it. Doing those two things, we've gotten, in the high 0.1s doing that, but anything beyond that, it's kind of impossible to do with that slipper.
Sure.
So, like 0.15, something like that is probably the best reaction time I've seen with that.
Yeah, okay. And I mean, the other benefit, I suppose, there as an aside, is you're already sort of preloading the drivetrain, so that's a little bit easier on everything.
Yep, exactly.
Now, this technique is unfortunately incredibly hard on the clutch, so you're purposely slipping part way or quite a long way through first gear to sort of manage that wheel spin versus ground speed. That's going to create a lot of heat in the clutch. I'm interested, what are you using in terms of an actual clutch in the cars?
So we have a Quartermaster triple disc, just their off-the-shelf Quartermaster triple disc.
So no carbon, nothing particularly exotic?
Nope.
And what sort of life expectancy you're seeing out of those?
I mean, we usually go a full race on one clutch and then we take it out. It could probably go a little bit further, but we're not going to go to a race across the country with a used clutch in it. So I mean, we're usually replacing it after every event. They're a good partner with us, and they sponsor us for the clutches, so that helps out a lot. With the carbon stuff, I found that we have tried it, and I found that the engagement is even more unreliable than say like the Quartermaster Cerametallic triple. It grabs pretty reliably. You can kind of anticipate what it's going to do. Those carbon clutches, a lot of times it's all based on like the amount of heat you put into them, and then like trying to put the same amount of heat in every time. I've come to the realization that the Quartermaster works great, But you're absolutely right. It's really hard on it, especially when you're slipping it a lot. And if you miss the clutch adjustment, like just by a little bit, you can literally roast the entire clutch.
Yeah.
So what I did is, in the tuning strategy with the clutch slipper, I talked about that line lock and being able to turn it off. So I have it also implemented into my race timer. So when I launch the car, it's only going to allow that slipper to work for, say, 0.5 of a second. And even if it is slipping like way more than it should be, it's going to automatically turn it off and kind of limit it. So that's how I got around smoking clutches, because I did that a couple times.
That's smart. I assume you're running that race timer off the clutch switch or two-step or whatever you're doing. So as soon as you go to launch the car, that race timer's starting.
Yeah, so we've tried doing it like that. The best way that I found to do the race timer is vehicle speed, but we don't use like the stock vehicle speed sensor, because the stock vehicle speed sensor is just, all over the place. And sometimes it starts reading when you're already going like 8 or 10 miles an hour. So we just got a high resolution drive shaft speed sensor.
Sure.
It's like a 16 or 18th tooth drive shaft speed sensor. And I start the race timer based on that. So as soon as the car sees some type of speed off the line, that's when the race timer starts.
Yeah, okay. No, that makes sense. Actually, I'll come back to what you were saying about the drive shaft speed earlier and Haltech with their torque profiling. I think that's basically what they call it. And for those who sort of heard it talk about that briefly, that's a process where if you look at the drive shaft speed as the car goes down the drag strip, and you can sort of get the profile of what a supposed perfect run would look like if the car's really hooked up, and you then use that as a sort of a target drive shaft speed versus time, and then that can be used as a traction control strategy, because essentially if the drive shaft speed spikes up above that profile that's supposedly ideal, that's going to mean the car's broken out into wheel spin, and then you can employ some strategies. So you mentioned you can't use that with a manual because the drive shaft speed is not as smooth as with a clutchless or an auto, which totally makes sense. And you also mentioned GPS, so I'm assuming there you were talking about trying to implement a GPS traction control strategy, because of course with a four-wheel drive car, if one wheel is spinning, all four are spinning, so you can't look at differential wheel speeds. That's what you were using that GPS for, or trying to?
Yeah, because the car's got a lock center diff, so it's a little bit different. Like, say an all-wheel drive car like a GTR, where it's more rear-wheel drive biased. I mean, you can still use that front wheel speed sensor and what they call like an estimated speed to employ like some kind of traction control strategy. But with my car and in the locked welded center diff, literally if one tire is spinning, all of them are spinning.
Yeah.
So there's really nothing you can do other than I tried the GPS thing, which doesn't work too good, and I also have a bit of a traction control strategy implemented based on race time in first gear. Okay. So we just use that.
Yeah. I mean, I've just personally been trying out a Cyvex 50 Hertz GPS in one of our road race cars, which I've seen some really good results. The data from it's super clean and obviously a much higher resolution. The problem is that most of the consumer grade GPS units that we come across are only 10 Hertz. So if you sort of zoom in on the actual trace out of that, it's only updating 10 times a second, which certainly isn't fast enough. Cyvex, I think, have actually just recently brought out 100 Hertz as well. So I'd be quite interested to actually dive in and see if one of those could be implemented. But again, if you've got something that's working, there's not a lot of point changing something that isn't broken. In terms of the future for the car, what's holding it back at the moment? It sounds like very much your traction limited. What needs to change, and what have you got planned for it? How fast can it go?
So I wouldn't say that it's honestly traction limited. We race the car, maybe 3 or 4 times a year, and it ends up being at, like major events. We'll go to TX2K, we'll go to FL2K, go to import versus domestic. And I often find myself in the situation to where, I'm trying to just put down a clean pass to qualify, to get up there. And I'm never really putting into the car what I think it could take,
Okay.
So
you're not really racing for PBs at that point. You're actually racing to stay in the competition.
Exactly. So, I haven't really put at the car what I think it's capable of, to be honest with you. Since we changed the suspension setup in 2021, we changed some spring rates and some stuff. And in 2022, the car has literally not broken traction once. Wow. Like, it hasn't even kicked sideways, spun, gotten loose at all the entire season. So I'm getting pretty confident with the car. And as we speak right now, it's actually on the way down to Orlando Speed World. for their, I think they call it like the Sport Compact Finals.
Sure.
So we're going to try and, pour it into the car in first and second gear and see what it can really take. But based on some of the data, the last pass, it went a 697, and that was almost a tenth faster than my 698 pass at the eighth.
Wow.
And I had some issues with some rocker arms, and it slowed the car down like almost a whole tenth on the back half. Okay. So I know for sure there's an 80 in the car. I mean, we basically had an 80 if the car would have just kept going to the end. So I know there's an 80 in it. I think if I, really pour some power in the beginning of the track, a 70 isn't too far off either.
Well, I mean, it's already impressive what you're doing with it. So being able to go even faster, I look forward to seeing where it ends up. One last element I just want to talk about with the car, because it is a sort of a distinguishing point, and I think you've sort of kept it as a sort of on purpose, is the fact it is manually shifted, it's stick shifted. A lot of people are running sequential gearboxes or sequential shifters. Back in the day, we used an air ram, and it was actually air shifted to make the driver's life easier. This has got to make your life harder and technically potentially slow the car down.
Maybe, I don't know. I mean, I've played with the air shifting the car too, and honestly, when you start implementing all these complicated things, a lot of times the results, you really don't get any better. You know what I mean? So that's what I've seen, that not only with me trying to do different things, just watching some friends that have air shifted their cars with the IKEA shifter, or all different types. They end up doing best. It seems shifting themselves. It's just driver's experience. And, when you look at the logs, I'm not really missing any shifts or like missing shift points or anything. So it seems pretty consistent. I feel like you can feel the car a lot better. You know what the car is doing versus just holding the wheel and just like, oh, there's the shift. Like you're actually feeling it and making it shift. So I'm sure maybe it could be faster, but I prefer shifting it myself. I've done both, and I prefer shifting it myself 100%.
Yeah, fair enough. I think when we built that Evo 9 that I referenced earlier, we had the IKEA shifter, but it was manually shifted. So for those who aren't aware, it basically converts the factory gearbox from a H pattern to a sequential. Works really nicely with a dog box, and we'd sort of gone and shaken the car down, and everything worked quite well. And unfortunately, the owner of the car had sort of stepped out of I think it was a 14-second Primera, and that's as fast as he had ever gone. And we sort of built him an 8-second car, and that's a steep learning curve. So he really struggled with it. And these engines don't really like being banged on the limiter for 5 or 6 seconds at 10,500 RPM. It doesn't really do a lot of good things for them. So we sort of went back and assessed what was going on, and decided, well, hey, look, this is an option that's going to make it nice and easy for the driver. It's going to suit what he needs, and it's going to keep the engine together. And it worked, so we never changed it. But I mean, if you're not missing shifts, I guess you still need that cut that we talked about to disengage the dog. So I guess you're not technically actually going to shift any faster, H pattern versus sequential versus air shifted anyway. So you're actually probably exactly right.
Yeah, I mean, I still think a sequential transmission is going to be faster than an H pattern, because you're still restricted by like the factory shift rails and the shift forks, to where like a sequential transmission is, like pulling the one shift fork as it's engaging the other shift fork. You know what I mean? It's on like a big cam. So
yeah,
I mean, a sequential trans, like we just installed one in an Evo 9 here, a Quaif. I mean, like it's a really, really nice trans. And I think that thing will outshift and will shift faster, not only because of the mechanical advantages, but because like the gear ratios are tighter.
Yep.
You know what I mean? So you don't have that huge RPM drop, to where like, maybe your transient response, maybe you could squeak a bigger turbo in there because you've got less RPM drop.
Yeah. I guess then you start trading off an additional shift down the strip and the time that you're going to lose that. But who knows? That's something that really needs to be tested to see what happens. All right, let's move on, and I want to talk a little bit about Boostin Performance itself. So let's start with maybe a 30,000 foot view of the operation as it sits. Where are you based? How many staff? What's the size of your facility?
Sure, we're based out of Hoffman Estates, Illinois, just outside of Chicago. We've got a 7,000 square foot facility here. It's got a 2,000 square foot office. I've got 3 full-time office staff. We've got 4 guys in the back that do everything from just general maintenance and repair to we build, 6-second GTRs. So we also have a separate room in the back. That's where I'm mostly at. We have a Mustang dyno, and we specialize in tuning the three platforms that we work on. So basically Mitsubishis, GTRs, and the new Supras.
Okay. How long at this stage has Boostin Performance been in business for?
So we're going on our 14th year in business. We've been here at this location almost 10 years now, and we started out at a smaller 2,000 square foot location, a couple miles away in Addison, Illinois.
I'm interested. We have a bunch of people following this show who either already own workshops or are maybe considering starting their own. So I'm interested to just get some understanding around your sort of headspace, mindset, etc. when you went from being employed to taking that leap of faith and going, hey, you know what, I'm going to do this myself.
Yeah, I mean, I think my situation might be a little bit different than most people's situation. I mentioned that one shop that hired me, and they were an Evo DSM Subaru shop. So I worked there for a while, and then I got picked up by another shop that just got a Mustang dyno. They were actually on the same street, and they weren't really known too much, this other shop. I went to work for them, and then a bunch of clientele started coming in and basically just requesting me, and I kind of got the feeling that, hey, I could probably be out on my own and these people are still going to come to me, because I was literally having at least half the customers come in like specifically mentioning Devin, or I'm here for Devin, or I want Devin to work on the car. So I just developed my name working for another shop, and it's not like I tried to screw the guy over or anything like that. We left on good terms, but I came to the realization that I had a pretty decent following, and I think a lot of it came from the car. Going 10s on the 16G and 8s on a 35R, and just slowly progressing with the car. It created, enough of a following. And, luckily I'm in Chicago, and it's a big, metropolitan area, and there's a huge customer base here. So,
yeah,
I was able to start my own shop, and we were busy from day one. I was busier than I can handle from day one. But, if I had advice for anybody else, it's mainly just about passion. If you have passion for it, when people start working with you, they're going to see that passion that you have, and they're going to want to be around it. So as long as you have passion for what you're doing, you can start your shop now, later, whenever. It's going to be successful as long as you work hard and you have passion.
I think what you noticed there with the fact you said you built up a following and people were bringing cars to this shop and specifically requesting you to work on them. I've seen that time and again all around the world with the tuning industry. It becomes the actual tuner who's doing the work on the keyboard rather than the shop. So yeah, I guess that makes natural sense. On that basis, was it not really much of a leap of faith to actually go and start your own shop? You were pretty confident it was going to work because these people were just going to follow you wherever you went?
I mean, looking back at it, I could say, yeah, but absolutely not. I was scared to death. I mean, I got the money to start the second shop by taking out a home equity loan on my house. So, I took the home equity loan out. I got every dime together that I had, and I started the shop. And no, I was scared. I mean, it was, and the first couple of years, you would slow down for a little bit, and you'd be thinking, oh my gosh, is this it? Is my shop done? And then, like, in a day or two, you'd have a full schedule. Luckily, it's not like that anymore. But man, it's definitely scary when you're stepping out there on your own.
Yeah. I think the good thing about the performance automotive industry that separates it from mainstream auto repair is, no one's really happy taking their car in to have a $1,000 service performed or have something broken fixed that when it's fixed, it's just going to perform like it did before. You're not getting an advantage. Whereas taking your car in for modifications, tuning, it's going to come out the other end better with more power or a new part or whatever. And I think that makes people really passionate about dealing with good quality shops. The other element, I think, to a degree, and I mean, it's not obviously recession proof, but in most instances, it's been funny. I've been in the industry now for 20 years. People always seem to find money for their toys, no matter what the economy's doing. Yeah, it might slow down, but I think it is relatively recession proof. Is that sort of been your experience?
So, when we started our shop, I think it was 2007 or 2008.
Oh, perfect timing.
Yeah, exactly. So, I mean, like, I was telling my family members, like, hey, this is what I want to do. And they were like looking at me like I'm crazy. Like, what are you thinking? Like, don't you see what's happening to everybody's business recently? And yeah, we just took the leap of faith and just went for it.
Yeah.
So
So you mentioned there, obviously, the DSM and Evo platforms, the GTR, which obviously makes sense. That's become a massive platform for modifications, and then the new generation Supra. How do you decide what platform to support? And have you got anything on your radar that you're sort of looking at as an up and coming platform that you think might be worthy of branching out into?
yeah, I mean, we recently picked up the MK5 Super. I mean, it's a really, really nice platform. It's a little bit different than say a GTR because you don't have a huge group of people that want to come up and build it from scratch to be a drag car. You know what I mean? It's a little bit different. You're just kind of doing bolt-on modifications, tunes, and honestly, I really like that because having a GTR here for months and being responsible for every aspect, it's nice. It's fun, but there's also something to be said about work that you can just come in, go out, the customer's smiling, you get to meet a new customer every day, and you're just making people happy. So that's been nice. But I think the next platform that's on our radar, I think we're going to be looking at the 400Z.
Mm. Yeah, that seems like an up and coming platform that's going to be really popular. Looks like it sort of ticks all of the boxes, and we see AMS at the time we're recording this have had some pretty good success. I think they went to the nines with it, I'm pretty sure, just recently, didn't they?
Yep, they're in the nines already, and it's helped. They've got all those parts for the the Infinity Q series, so they've been able to transfer a lot of the VQ30 parts over and hit the ground running. So
Yeah,
we work
absolutely.
with AMS. We're an AMS distributor, so we'll have access to all that stuff, and just like the GTR platform, they've helped us along the way. So that's definitely something that we'll be looking to do again with them.
Excellent. All right, Devin, well, we'll move towards wrapping this thing up. I want to respect your time here, and we've got the same three questions for you that we ask all of our guests. The first of these is what's next and in the future for you? Obviously, we've just talked about the 400Z, but on a broader scale, what do you sort of see in your future and in Boostin Performance's future?
Sure. So just recently had another baby, had a 7 month, I have a 7 month old little girl. I have a five-year old boy also, and just kind of enjoying racing and enjoying the shop with the family. I don't have any aspirations to make this, a 30, 40 man operation or anything like that. I mean, I really just enjoy doing what I love every day, having fun with customers, going racing, and just making a living doing it. I don't need to make a ton of money as long as I can support myself and do, race. I'm good to go. Something that I would like to do and that we've looked into is maybe opening a second location, maybe someplace down south in the U.S.
Sure.
Maybe in the next 5 years or so. That would be something cool to do. Just try and get this facility somewhat, self-sustained and operating on its own, and then I could kind of, branch off and get something else going down south. So that's maybe long-term goal. That's kind of where we want to see ourselves.
I mean, it makes sense. The US obviously a massive country, so lots of customers there, but geographically it's also quite spread out. I think what you said there also bears repeating. If you're passionate about what you do and you're doing something you really enjoy, essentially work is not really a chore. The old saying, if you do what you love, you'll never work a day in your life. And I mean, there's always the good parts and bad parts of every business. I don't want to sugarcoat it, but certainly it beats sort of working away for 30 or 40 years at a job that you hate, which unfortunately a lot of people are in that situation. So I think it bears repeating there. Next question for you, Devin. Is there any advice that you'd give to a younger version of yourself, or maybe one of our listeners, that would help fast track your career progress, get you to where you've got to in your career a little bit sooner, and maybe avoid any pitfalls if you've come across any?
Man, fast track it. I'm trying to think. How would I be able to fast track what's happened? I don't know. I don't think really there's any way to fast track it. I just think it's just putting in your time, putting in your work, whether it be racing, whether it be tuning, whether it be wrenching. You just got to put in that time, and it's not going to happen overnight. It's going to take years, sometimes decades. But, as long as you're doing what you like, I love what I do. I can't say that I haven't worked a day in my life. I definitely have, but we all have those days. But, I often find myself coming back from lunch, like really looking forward to walking back into the shop because I've got a GTR in the dyno or just something really cool. And, I'm just fortunate that, God has put me in a position to where I'm doing what I love and my family's taken care of and everybody's happy. So
Absolutely. All right. Last question for today, Devin. If people want to find out more about you, more about Boostin Performance, and follow your journey, where are they best to do so?
Sure, we've got a website, boostinperformance.com. You can always give the shop a call, 847-781-1600. We're on Facebook, Boostin Performance. We're on Instagram, Boostin Performance. We're all over the place. So
Cool. All right. Well, we'll put some links to those social media profiles in the show notes as well. Make it super easy for people to find you. Again, thanks heaps for your time today, Devin. Really been interesting getting some insight. Obviously, I've been using it as a bit of a personal learning curve here because I'm still an Evo guy at heart. But great to chat, and certainly on the Evo or DSM front, I look forward to seeing how much lower you can set that benchmark with Red Demon. Cheers.
well, thank you so much for having me. It was a pleasure, and I often watch a lot of your videos, and you're doing good things for the community and just spreading the knowledge. And like I said, I can see your passion oozing from every video that you make. So thank you for what you do.
I appreciate it. All right, thanks, Devin.
Have a good one.
If you enjoyed this episode of Tuned In with Devin, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt anywhere in the world free of charge. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Giles Performance from the United States, who has said, great podcast. If you like the technical side of motorsports, this is the place. Possibly the only podcast and YouTube channel like it. Keep up the good work, Andre and HP Academy. Well, thanks for the kind words there. And if you get in touch with your t-shirt size and shipping details, we'll fire a fresh tee straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.